Greetings and welcome. This is a presentation of procedural notation. We will be looking at logarithms. Logarithms are generally the bane of most algebra students' existence. The oddness of using a functional word as a pseudo-hyperoperation is quite likely to throw students off, especially when you leave out the base parameter of the operation. That's a problem. So here we have log 10 of 100 is equal to 2, whereas 100 log 10 is equal to 2. So visibly read from top to bottom, the syntax is verbally spoken slightly different than log 10 of, and then a subunit. We read it 100 log 10. And here's very good reason for students to be confused in traditional math class. We have our exponent over here of a to the power b equals c. Comes in this form with the little b. But then if we rotate our operations, as this is related to the rotation of the exponent's operators, suddenly we have a different positioning of order. So how do we read this out now becomes a little bit different. We don't read the base first. Now we are starting with the function first. Function, then unit, then the value to be evaluated. And then if we introduce a particular base component, suddenly we change the name of the function altogether and we hide the symbol, and that means that we have to learn a whole second set of rules for that set of identities. And so yes, students should have a good reason to struggle with logarithms. Now, one of the things we can see here is the division symbol seems to be related functionally to the logarithm, because they are. We are counting how many times do we evenly divide to get to a new base. This is an integration of the division symbol with the exponent and evoking a little sense of rotation to express the relationship between these elements. Also, by using one operator as a universal logarithm symbol, we get rid of this ln, lb, lg, log missing operand. You must fill in the base parameter. You can't simply leave the log symbol. It will not be logical. It is completely missing a parameter if there is no base operation, a base parameter to that operation. It's a critical component of your logarithm. And as it turns out, because there's a whole second set of identities for natural base to regular identities, they set up a whole duplicate set of identities that you have to remember. This rule applies to natural base no differently than any other number. Here, Euler's number, an approximate value with that curvy symbol here, is just another number. It's no different than any other number when it comes to your logarithms, but because ln has that e built into it, you have to learn a whole extra set of logarithmic identities to just deal with that special case of being ln. If we get rid of that function altogether, you cut the number of identities you have to know or consider in half almost, because there's not a duplication for each special case of when it's e or when it's some other number. They all behave the same. So while e is a very important mathematical number, especially in things like derivatives and integrals, we don't really need to be giving ourselves a second set of operations for that number. What we need to do is clearly understand what the logarithm is doing. We're extracting the exponent from a number. Here I'm undoing the base, if you will. So I've taken a number y raised to the power of x, and I want to undo the act of y. So I'm replacing my base with its sort of opposite, and I'm canceling it out, and that is really the function of exponent. Here we see y raised to the power of, and then in here I have x and log y. Think of it as the unbase. So this unbase cancels out this base, and I'm left with x. That's kind of hard to intuit, especially when your font size becomes too tiny to read. And so here we can see an example of the change of base formula we looked at earlier. It is x log y is equal to x log z divided by the value of y log z. So here we start with the inner contents when we speak in procedural and work our way out. And we occupy really no more space. I've actually used a larger font for the procedural, so comparatively, in terms of space compression and use of space, I would say that the log operator really helps in terms of being able to make the best use of your real estate on paper. Here we can see how nicely they match. X to the power of y log z is equal to x log z times y. And we can say y times the value of x log z as two equivalencies here without having to involve this square root radical symbol or the positioning of the division symbol, and then remembering that this is a group on the above and a group below. This does all of your grouping for you. This is your group. Every operation before your current operation is a group, so x to the root of y is its own group. Think of that as a subunit. We then take that input and we run it through log z. So as you go down your steps, each step is a subunit. Sometimes it's easier to see the relationships of things. Yes, it is still easy to see that we have a fraction here. I have a numerator and a denominator. Every time you run into this diagonal symbol, you know you're looking at a fraction. So here, a fraction, log y, is equal to negative subunit of x log y. So the value of x log y, negative, is my little subunit here. And here's some more identities. Here we have x times y. These could be put right next to each other, so it could be xy log z is equal to x log z plus y log z. So here we see the multiplication and the division are clearly related to the addition and the subtraction. And just visually, if you don't have to worry about matching ln and log with other logs and ln's, and you can just visually say, what am I doing? Exponent, root, log, exponent, root, 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 log, log, and just count that way. I think it's much easier to go through and handle dealing with your equations. I hope some of this has been useful and helpful. If you have struggled with logarithms, believe me, you're not alone. And I myself was not very good with them until I started doing this. And I found that it is just about the easiest way to do things. So if you want more information and would like to see more videos, go ahead, like and subscribe. Please consider visiting my Patreon to support the production of the final book. And I'll give you some previews of more material as I'm coming up with it. So thank you very much, and have a nice day. Take care, and I will see you around soon. Bye-bye.